Today we will be studying about existence of stream function and velocity potential function in fluid flow. So, moving towards stream function, let us consider a simple case of incompressible 2D flow like in xy plane. The continuity equation for the Cartesian coordinates can be del u over del x plus del v over del y is equivalent to 0. This was the Cartesian coordinates for 2D flow of continuity equation. Now, there comes a variable transformation to write this or to rewrite this equation in the form of a single term psi, that is nothing but stream function, and this single stream function replaces the two other variables which are being found as u and v. That is, if we are calculating v with the help of velocity in x direction and velocity in y direction, this single components or these components can be represented or replaced by a single component psi. So, we define psi as nothing but its partial derivative in any direction gives us the velocity component in the direction we have calculated right angle to it. Like if we are calculating the psi or partial derivative in x axis, the velocity component which we will be getting will be 90 degree, and that is v component, and if we are calculating the partial derivative in y direction, then the velocity component which we will be achieving will be u component or u. Now, question comes, why this particular stream function exists and how do it exist? What is the assurance that its role is vital or its existence is there while the fluid is flowing? Now, you can see previously you have seen this was the equation for continuous equation for 2D flow. From the streamline function or psi definition, we have calculated u and v. So, we will be substituting the value of u velocity component in x direction, v velocity component in y direction in continuity equation for 2D, because if it might be existing, then it should satisfy or it should be placed within the continuity equation. So, we have substituted the value of u and the value of v in this function, and then there you can see that the coming equation or the resultant equation is nothing but in the form of Laplace equation. It means that if you have to calculate or you are sure about the existence of psi with coordinate x and y, then it should accept or it should be applicable for or it should be satisfying the Laplace equation over in the form of the same form. Now, the question comes, we have reformed a variable psi and replaced the two variables u and v. Now, what is the gain or what is the benefit we have got from this single transformation? There are two benefits in which you can see, first of all, a single variable is being replaced by two other variables u and v in this particular equation of continuity equation. Second one, you can see that with the help of stream function or with the help of line drawn with the stream function, having that stream function as constant, we can help or we can draw the curves of constant that are nothing but streamlines of the flow. Here you can see this particular streamline, how we can define or how we can construct. We have considered a streamline in xy plane with certain coordinates. Let us take a point with coordinate x and y. So, we have marked over it. Then when this particular fluid particle moves from coordinate x y to coordinate x plus dx and y plus dy, there will be you will be getting another coordinate, and hence you can draw a streamline along these coordinates. Similarly, in similar pattern, keeping this psi constant, psi as constant with psi 1, psi 2, psi 3, here you can see psi 1, psi 2, psi 3 and psi 4, you have drawn or you have got a curves or the curves number of curves with psi as constant that are nothing but streamlines of drawn with the help of stream functions. So, here you can see these are the curves of constant function which are representing streamlines, and streamlines are nothing but imaginary line which help us to calculate the velocity component in x and y direction. Now coming to the velocity changes or velocity functions, which you can see the change in the velocity of psi is being represented by xy at one point and x plus dx and y plus dy at another point. So, these points could be represented as a function of space and time, and there you can see del psi can be written as change in psi in x direction with respect to the distance covered dx plus change in psi with the in the direction dy after covering a distance of dy, and hence it is representing that psi is a function of x coordinate and y coordinate. Then you can see this is nothing but, as per definition, del psi over del x. Previously you can check it out, del psi over del x. Del psi over del x is nothing but minus of v, and del psi over del y is nothing but u. Substituting this value, you are getting it as minus v and this is u. From this we can have for slope of this value, and slope can be calculated at del y over del x will be nothing but component or relation or ratio of velocity in y direction to velocity in u direction, keeping in mind that you have kept the psi as constant. Here you are getting equating this psi and this psi, this value will be equivalent to 0, and hence you will be getting a line of constant along these parameters as v and u, and hence we can draw n number of streamlines with the help of this equation. This you can see x and y coordinates are there, and these blue lines representing streamlines, they are having velocity components corresponding x and y and resultant velocity, and hence with the help of these coordinates you can draw n number of streamlines. Coming to the streamlines, along a streamline what you have seen that you have calculated the slope with the help of velocity component in y direction and velocity component in x direction, wherein you can see that the velocity component in v direction is nothing but change in psi with respect to distance or direction x, then change in psi or stream function with respect to the distance travelled in y direction. And hence in equation number 2 you can see that we can redefine the main equation and can write in this form, and further calculations can be made. But for any smooth function like for psi, or psi having certain coordinate x y, then psi will be having certain coordinate x plus dx plus y plus dy, therein they will be having either tangential velocity or radial velocity. For that 3D coordinates, another line of equation you can calculate or you can write it down. This is the equation for psi, and it is for representing the another coordinates which are being presented to the type of flow. Now we will be coming to the velocity potential function after covering streamline function. Streamline function can be summarized, or 2-3 major points we can recall, that it is applicable for 2-dimensional flow. Then it is a single variable, that is psi. It is being replaced by the 2 variables vectors, that is velocity vectors u and v in corresponding directions x and y, and therein you can see with the help of this psi we can draw the curves of constant or streamlines of variable flow within the flow field. Coming to the second portion, or existence of another constant, that is nothing but velocity potential function. So, as the previous definition was, previous existence of stream function was that partial derivative in any direction gives the velocity component right angle to that direction, wherein in velocity potential function this variable is in the form where its negative derivative gives you the velocity component in that particular direction. So, here you can see that velocity component in x direction, its negative derivative in y direction, in z direction. So, as per the definition or as per its existence of that particular one variable, what we are supposed to see, first of all we need to know that psi, that single variable which is going to replace all the three velocity vectors in respective directions will be dependent on the coordinates x, y, z and time delta t. So, here you can see by definition or by existence we have seen this single variable is present within the flow. With the help of these variable we can coordinate or we can calculate the corresponding velocity in respective directions, whereas this psi or you can say stream function was represented by psi, and here velocity potential function will be represented by phi. In vector form you can see that the equation can be written in this form. Now, the thing is that for an irrotational flow the velocity is expressible as a gradient of what? Scalar function of phi, and then velocity potential is a consequence of irrotational ability of the fluid flow, whereas the stream function is a consequence of conservation of mass. This is the major difference. We can note it down, this point, that it is a consequence of irrotational ability of the fluid flow, while stream function is a consequence of conservation of mass. Another thing which we can note it down or which we can see, the velocity potential function can be defined in 3D forms, whereas the stream function is restricted to 2D only, which we have already discussed. Now, for conservation of mass we can write the equation in this form, and if this incompressibility or rotational flow is having velocity as this, then the equation will be coming in the square form, and hence again we can see that the existence of psi, psi is stream function, but we are discussing about velocity potential function. Then again velocity potential function, by definition you can see u, v, w is there. Its existence will be valid only and only if it satisfies continuity equation, and continuity equation is nothing but change in velocity in x direction plus change in velocity in y direction plus change in velocity in z direction should be equivalent to 0. So, here what we can do, we can replace this u, v and w, with the parameters given by psi, and there you can say after substituting this value it is again coming in the form of Laplace operator or Laplace equation, which is nothing but if psi is existing then it should satisfy the Laplace equation. Second, if phi is existing or velocity potential function is existing, then the flow should be irrotational, and where we can check the irrotationability of the fluid flow. Now, coming to the differential equation in various areas you can see of engineering mechanics, Laplace equation plays a very important role, and where if you talk about fluid, then incompressible irrotational flow fields are specially governed by the Laplace equation. We have already seen in many equations and many topics, and hence this type of flow is commonly known as potential flow, and potential flow are always irrotational, we have already seen. Or you can say if there is existence of phi or velocity potential function, then we must be sure that the flow having that particular field will be irrotational, and it may be due to any point. Again here the vorticity is 0 throughout the flow. Now, this is the Laplace equation, you can see it is in the form of polar coordinates, where radial and tangential velocities are considered and radial radius and angle of formation is being asked. Coming to the vortex flow. Vortex flow is one of the most important flow while we were discussing about the streamlines or the lines with constant stream functions or flow net. Vortex flow will be one of the most important, and vortex flow is what actually when the fluid particles follows a circular path to flow. it forms a vortex flow. Or you can see that whenever you are seeing, if this is the free surface and the fluid is flowing over here, and here you can say this particular path line is linear. But in the same case, if this path of particle is not linear but circular, like particle moves from one point to another point in a circular way, unlike this one where particle was moving linearly from one point to another point, then this particular flow will be known as vortex flow. Now, vortex flow is being divided into two parts. Vortex flow can occur naturally or it can occur by providing external torque to it. So, basically dividing the vortex flow into two sections. Forced vortex flow and second one is free vortex flow. For forced vortex flow, you can see that when external torque is provided to make that path line of the fluid particle circular. Here you can see, if you are taking a jar, a juice jar, you can take a juice jar and you are keeping it in on position, and there you can see the fluid or the juice inside the jar follows a circular path. So, that circular path is being operated by the external force which we have provided to that juice and the jar. So, this can be considered under forced vortex flow. Coming to the free vortex flow, where free vortex flow you can see that if there is a tank or reservoir at a point and that reservoir is having a hole at the bottom of it, then the fluid flowing through that hole will be having a free vortex flow because it is following a natural or by default phenomenon of circular path it is having. Next you can see, or we can discuss, we can move forward. We have considered a field in which streamlines are concentric. Concentric, again there is a center and n number of circles are there, that is interchange of velocity potential and stream function for this particular source. We have kept this center as a source and we have considered that it is having a concentric, it is forming a concentric circle of what? Stream function and velocity potential function. So, here you can see this in the form of velocity potential function and this is for stream function, wherein k is a constant. In case the streamlines are concentric, then the velocity, radial velocity will be taken at 0. Other equation for polar coordinates, you can see that it is nothing but velocity or tangential velocity can be calculated with the help of ratio of k by r, where k is a constant and r will be the radius of this concentric circles, and hence you can draw the n number of concentric circles with those parameters. And here the results represent the tangential velocity is inversely proportional to the radius or distance from this origin. This you can see 1 by r mean tangential velocity is inversely proportional to the radius which you have provided with the radius you have from this origin. This is the origin of the flow, this is the origin of flow you can see, and from here you can see if we are going to calculate tangential velocity, then it is seen that, or it is proven that it is always inversely proportional. These are under the results. Coming to circulation, in circulation you can see any line integral of velocity component is nothing but circulation. Here you can see, let us consider, let us draw two components x and y. We have taken two xy planes and corresponding velocity components as x direction u and y direction you have taken at v. Now, let us substitute one fluid in this xy plane. Let me change the color so that we can have let us suppose A, B, C and d. This is a fluid component we have kept in xy plane, and now this distance could be written as dx and this distance could be written as dy. Then we will start the flow of fluid from point A, or keep it A as the origin, and we will keep on moving the entire fluid element in corresponding x, then y, then again another side or negative side of x, then again in y, and we will come back to the origin point A. For this calculation, you can see that if A point is having e velocity, then moving to AB, it will be having velocity u plus change in velocity in x direction after covering a distance of x, AB, and corresponding B, C, C, D and D, A. And hence, instead of calculating single parameters, we can consider that velocity component should be represented as a line integral, and hence it can be calculated, and this particular path will be known as circulation. Now, for irrotational flow, we have seen that velocity is being calculated with the help of stream function, and then stream function is again but nothing but components with the help of u, v and w, and hence this particular equation is being found out, that is line integral of psi. Psi is nothing but presentation or replacement of u and v vectors in their corresponding areas or corresponding axes. This is to be remembered for calculating the circulation within a flow field. This result indicates that for an irrotational flow, the circulation will generally be 0. Here you can see, if it is irrotational, the amount here you can see, if you are substituting this value and it is irrotational, means there is no rotation, then this circulation value will always be 0. I will underline it up. But for free vortex flow we have covered previously. Free and forced vortex, forced will be external torque where we have provided, and free where the water or the fluid particle are free to move in a circular path due to their n number of reasons. Now, here you can see, for the free vortex flow, if tangential velocity is taken as k by r, where k is a constant and r is nothing but distance from the origin to that concentric circle, where you have drawn as phi as constant or psi as constant. Then circulation can be calculated with the help of this formula, again substituting k by r, and r d theta will be nothing but the distance covered by this particular fluid element to 0 to 2 pi. Now, this circulation where psi is existing and where we are substituting the value of tangential velocity as k by r, there you can say that circulation will be non-zero or circulation will be existing. But for irrotational flow, the circulation around any path does not include a single point, that will be 0. Now, coming to circulation, the velocity potential and stream function for the free vortex you can see can be expressed. Psi will be velocity potential function and here psi will be stream function. They both are being represented in the form of stream function and velocity potential function in the form of circulation. This you can see. So, in our today's lecture, what we have covered that there is an existence of a constant or a variable. There is the existence of constant variable psi which replaces u and v. Then coming to next one, there comes phi which can replace u, v and w, and they both should satisfy Laplace equation. because it comes under the section where you can see Laplace equation is achieved only and only when we have substituted the corresponding value of psi and phi in our continuity equation, because continuity equation is the prime base for calculating whether it is a case of flow or not, whether there is any chance of possibility of flow in the field with certain coordinates or not. The next one, with the help of this we have studied two further more topics, those are circulation and vortex flow. Again, vortex flow can be of two type, where you can see it is forced vortex and free vortex. With the help of these force and free vortex, we can also study about the source sink formation of doublet, which is nothing but the case of u and v only, source where the particular point or the flow is radially outward, and that particular section will be known as source radially outward, and this is known as source. It is also under vortex flow only, because vortex flow is nothing but in circular path, flow in circular path. Similarly, if you find a place where the flow is coming radially inward in this circular pattern, and since it is coming radially inward, then this particular formation of flow will be termed as sink, and the place where both of these sink and source are available can be termed as doublet. Doublet formation. This is an extra topic which I just recalled because of the vortex flow. In detail, when we are going to study about vortex flow, then these formations of source and sink, doublet and half body formation comes. In our next lecture series, we will be studying about the Bernoulli's equation and Euler's equation and its application. Thank you.